Hello, I'm Timothy Purcell, and today I want to work a problem involving the future value of an ordinary annuity for my Math 1324 class. Here's the problem. Find the final amount in the following retirement account in which the rate of return on the account and the regular contribution changes over time. The account starts off with deposits of $1,200 per quarter invested at 6.3% compounded quarterly for 10 years, and then $1,800 per quarter afterwards invested at 7.8% compounded quarterly for 16 additional years. So we're looking at a 26-year timeline here. We're looking from now, 0 to, let's see, for 10 years, and then there's 16 additional years where they've upped the deposit to $1,800 per quarter. So that would be what, a total of 26 years for this problem. During the first 10 years, they're depositing $1,200 per quarter at 6.3% compounded quarterly. Remember, for these formulas to work, these annuity formulas to work, the compound period and the payment period have to be the same. If they're making their contributions quarterly, they got to have the interest being compounded quarterly. And that's what we have here. Notice they don't give us any information to help us decide whether this is an ordinary annuity or an annuity due. They don't tell us, oh, the payments are made at the end of the period or at the beginning of the period. So we have to assume this is an ordinary annuity. If no information is given to you one way or another to make a decision, assume ordinary annuity. The lump sum will occur after 10 years. That's in the future. So we're looking at a problem involving the future value of an ordinary annuity. And we know that formula and the S value, that's what we don't know. The S value, that's the future value. The amount of the payment, we're making, what, $1,200 deposits per quarter, and we're doing it for 10 years, 4 payments a year for 10 years, so there are 40 total contributions, and the interest rate at 6.3% compounded quarterly. So you take the 0.063 and you divide it by 4. Substituting those values into the formula for the future value of an ordinary annuity, we have S equals 1,200 times 1 plus I to the n, which is 40, minus 1, all divided by 0.063 over 4. So punching this into our calculator, I don't know if you can see this display or not here, but punching it in, if you can see it, let's see, we're going to get, I like to do the bracket amount first, so that is 1 plus 0.063 divided by 4 raised to the 40th minus 1 equals, I don't know if you can see that or not, and then I divide it, no, not minus, I divide it by the 0.063, and that gives me a 55.13743152. I then multiply that by 1,200 to give, after 10 years, the account balance is $66,164 and I'll round this to the nearest cent, 92 cents. You'll notice the final answer is to be rounded to the nearest dollar, but we're not going to round until the very end. Then we'll worry about rounding to the nearest dollar. But for now, I'm rounding to the nearest cent. And so at this point, the account balance on our timeline is $66,164.92. That money is now going to sit in the account and earn interest for the next 16 years, from year 10 to year 26. But there are two things going on during the last 16 years. That $66,164.92 has to be moved forward, but they're also making contributions. Here during the last 16 years, the interest rate has gone up, and so this person's decided to put more money into the account. They're depositing $1,800 quarterly, and 7.8% compounded quarterly. So the first thing we need to do, let's move this $66,164.92 forward. We're going to move it forward. All that's being added to that $66,000 plus dollars is interest. So we have to move it forward on the timeline by adding interest. That's a compound amount problem. We're going to have to use our compound interest. All that's being added is compound interest. So, moving that forward, using our compound amount formula, there's the compound amount formula, 66,164.92 is the principal times 1 plus our I value. The I value, you take the annual rate, that 0.078, divide that by 4 because it's quarterly. Now, how many quarters are there over this 16-year period? There are 16 years. There are 16 years, 4 quarters per year, so that's a total of 64 quarters. So punching that into our calculator, we get that $66,164 is going to grow to $227,724.90. So this amount, I'm going to circle this, although this isn't really a final answer, but the $1,200 quarterly at 6.3%. For 10 years you were making the deposit, and then the next 16 years it just earned interest. We have that amount it's grown to at the end of the timeline. We still have to worry about that $1,800. The $1,800 quarterly at 7.8% for 16 years. Now that's an example of an annuity. So that's another ordinary annuity. So we're going to have to use our ordinary future value of an ordinary annuity formula again. S, we don't know. R is $1,800. I, it's the same way we calculated I here in the compound interest portion of the problem. It's a 0.078 divided by 4. And N, same way we calculated it up here. They're making the contributions 4 times a year for 16 years for 64 total contributions. So substituting into the future value of an ordinary annuity formula, the $1,800 per quarter is going to grow to a total of $225,000. Punching this into our calculator, I'm getting a $225,394.80. So at the end of 26 years, we have that $227,724.90. We also have this amount here. Both of those amounts are in the account at the end of 26 years. So what do we do to these two amounts to get the account balance? You add them together, so the future value is the $227,724.90 plus $225,394.80. Adding those together, we get $453,119.70 in that account. But coming back to the problem, it says round your final answer to the nearest dollar. So here inside the box, we'll type 453,000. It's $119.70. So to the nearest dollar, that would be $120 for my final answer. Realize every time the payment amount changes or the rate of return changes, you have to use the future value of the ordinary annuity formula again. Here the payments and rates only change twice, but every time the contribution or the interest rate changes, you have to use the formula. Here was the one we did first. Here's our first application of it. Here's the second application. And as soon as the payments stop, that amount has to be moved forward using the compound amount formula. So, I hope this example helped you. For those of you, those are my students that are having trouble with annuities. I will. I'll post this online for you. Once again, this is Timothy Priscilla. Bye-bye.